Hi friends, welcome to the part 2 video of speed, time and distance. Today we will see two topics in speed, time and distance. I have left one topic for part 3. Yes, there will be part 3 video for speed, time and distance. I can teach you all the topics in the same video, but it will be like bombarding you with a lot of information in the same video. So there will be part 3. As I said, speed, time and distance is an important topic. So I think there is nothing wrong in spending time for the topic which is so important, right? So let us revise what we saw in the last video quickly. Yes, with this one diagram, as I said, with this one diagram, we can easily remember the formula for speed, time and distance. To find distance equal to speed into time. The formula for speed is equal to distance by time. Similarly, time is equal to distance by speed. Time is equal to distance by speed, right? Speed is equal to distance by time, distance equal to speed into time, time is equal to distance by speed. To convert kilometer per hour to meter per second, you need to multiply speed into 5 by 18. If you see the previous video, you will know how we derived 5 by 18. Similarly, to convert meter per second to kilometer per hour, you need to multiply speed by 18 by 5, right? To find the average speed, you need to divide total distance covered by total time of the journey. Let me explain what is average speed. If person A is traveling from Chennai to Kanyakumari in one stretch, he is traveling in different speeds, right? From one point to another, he is traveling at different speed. So to find the average speed for the whole journey, you need to divide total distance covered divided by total time of the journey, right? So like this, you can calculate the average speed. To find the relative speed, when two objects are moving, you have to consider their relative speed instead of their individual speeds. Like, let me explain. If two objects are moving, right? So, object A and object B, it is moving in the same direction at the speed of x kilometer per hour and y kilometer per hour. In this case, to find the relative speed, if x is greater than y, you need to do x minus y. If y is greater than x, to find the relative speed, you have to do y minus x, right? If two objects are moving in the opposite direction, object A and object B, suppose if they are moving in opposite direction, object A is moving at x kilometer per hour, object B is moving at y kilometer per hour, then to find the relative speed, you need to do x plus y, right? So like this, you can identify the relative speed. Before seeing today's topic, I need to clarify one thing. The last video, there is a correction in example 1. If Joshua drives his car at a speed of 150 km per hour, then the time taken by him to cover 900 km is, what I did, I chose 4 hours as the right answer, but that is the wrong answer. Why? When dividing 900 by 150, 15 6 are 90, right? So 15 6 are 90. So instead of 6, I chose option 4 as the right answer, but that's the wrong answer. So option C, that is 6 hours. 6 hours is the right answer. Okay. Let us move on to today's topic. Problems related to moving objects. Rule number 1. When a person travels a distance at speed of x kilometer per hour and returns the same distance at speed of y kilometer per hour, then to find the average speed, see, a person A is traveling certain distance at a speed of x kilometer per hour and returns the same distance at speed of y kilometer per hour. So to find the average speed for the whole trip, the formula is 2xy divided by x plus y. Let us see the example for this. A person travels from x to y at a speed of 40 km per hour and returns by increasing his speed by 50%. What is his average speed for the whole journey? So, a person travels from x to y at 40 km per hour. So when returning, he is increasing his speed by 50%. When returning, he is increasing his speed by 50%. So let us see how to solve this problem. Speed from x to y is equal to 40 km per hour. So speed when traveling from y to x is equal to 50% of 40 km per hour speed. So 40 into 50 by 100, which is equal to 4 5s are 20 km per hour. So the speed when he is traveling from y to x is equal to 40 plus 20, which is 60 km per hour. So now we have the speed from which he traveled from y to x, right? Now let us apply the formula. So what is the formula? Average speed is equal to 2xy divided by x plus y. So average speed is equal to 2xy divided by x plus y. Let us take 40 as x and 60 as y. Okay, so 2 into 40 into 60 divided by 40 plus 60. So 2 into 40, 80, 80 into 60. So what is 80 into 60? 4,800 divided by 100, the 0 and the 0 is equal to 48 km per hour. So option C is the right answer. Yes, option C is the right answer. So rule number 2, when a person travels a certain distance with a speed of x1 km per hour and then further the same distance with the speed of x2 km per hour and then further travels the same distance with the speed of x3 km per hour and so on, then average speed of the complete journey is given by average speed is equal to n by 1 by x1 plus 1 by x2 plus 1 by x3 so on to 1 by xn kilometer per hour, right? So let us see the example for this. Example 2. A car travels first 1/3 of a certain distance with a speed of 10 km per hour, the next 1/3 of the distance with the speed of 20 km per hour, and the last 1/3 distance with the speed of 60 km per hour. So the average speed of the car for the whole journey is, so we have to find the average speed. Here x1 is equal to 10 km per hour, 10. x2 is equal to 20. x3 is equal to 60. n is equal to 3. So what is the formula? n by 1 by x1 plus 1 by x2 plus 1 by x3, right? So average speed is equal to n by 1 by x1 plus 1 by x2 plus 1 by x3. Here we have x3, right? So we are stopping with x3. So apply the value. N is equal to 3. 1 by x1, that is 1 by 10 plus 1 by 20 plus 1 by 60. Let us take the LCM for 10, 20 and 60. Let us take the LCM 10, 20, 60. 5 2s are 10, 10 2s are 20, 30 2s are 60. 5, 1 5 is 5, 2 5s are 10, 6 5s are 30. 2, 1, 1, 3 2s are 6. So what is LCM? 2 5s are 10, 10 2s are 20, 23s are 60. Okay. So 3 by 10 6 are 60. So 6 plus 20 3s are 60. So 3 60 1s are 60. So 1. is equal to 3 by 6 plus 3 plus 1, 10 by 60. So when you move 60 here, it will become 3 into 60 divided by 10, which is 6 3s are 18. 180 divided by 10. So 0 0 is equal to 18 kilometer per hour. So option A is the right answer. Yes, option A is the right answer. Rule 3. When a person travels d1 distance at a speed of x1 km per hour, d2 distance at a speed of x2 km per hour, d3 distance at a speed of x3 km per hour, and so on. The average speed of the complete journey is given by, this is the formula, d1 plus d2 plus d3 divided by d1 by x1 plus d2 by x2 plus d3 by x3. Let us see the example. If a person travels 10 km distance at a speed of 5 km per hour, 27 km distance at a speed of 3 km per hour, and 35 km distance at a speed of 7 km per hour, then find the average speed of the journey. So here d1 is equal to 10 km, d2 is equal to 27 km, d3 is equal to 35 km. Similarly, x1 is equal to 5 km per hour, x2 is equal to 3 km per hour, and x3 is equal to 7 km per hour. So what is the formula? Average speed of the journey is d1 plus d2 plus d3 divided by d1 by x1 plus d2 by x2 plus d3 by x3. So average speed is equal to d1 plus d2 plus d3 divided by d1 by x1 plus d2 by x2 plus d3 by x3 kilometer per hour. So apply the value. 10 plus 27 plus 35 divided by 10 by 5 plus 27 by 3 plus 35 by 7. So we can cut this like 1 5 is 5, 2 5 are 10, 1 3 is 3, 9 3 are 27, 1 7 7, 7 5 are 35. Is equal to 10 plus 27 plus 35 divided by 2 plus 9 plus 5, which is equal to 10 plus 27 plus 35 is equal to 72 divided by 2 plus 9 plus 5 is equal to 16. So 16 5s are 6 5s are 38. Okay, so we have 72. 16 4s are 6 4s are 24, remaining to 64. So sixteen fours are 64. So remaining 8. So we have remaining 8. If we keep the point, 0 will be added here. So 16 5s are 80, right? So 4.5. So average speed is equal to 4.5 kilometer per hour. So option B is the right answer. Yes, option B is the right answer. So rule number 4. When a person changes his or her speed to x by y of his or her usual speed and reaches early by a minute, then usual time taken by the person to reach his destination is actual speed is equal to a by 1 minus y by x minute. So this is the formula. Let us see the example. If a bus runs at 4 by 7 of its original speed and reaches a place 3 hours early, then the actual time taken to travel the distance at its original speed is, so we have to find the actual speed. Here a is equal to 3, y by x is equal to 4 by 7. So what is the formula? Actual time is equal to a by 1 minus y by x. So a by 1 minus y by x minute, right? So apply the value 3 by 1 minus 4 by 7. So 3 by, if we cross multiply 1 and 7, 7 minus 4 by 7. So when moving 7 here it is in division, right? So when we move 7 to here, it will become multiply. So 3 into 7 by 7 minus 4 is equal to 3, which is equal to 7 3s are 21 by 3. So 1 3 is 3, 7 3s are 21, which is equal to 7 hours. So 7 hours is the original speed. So actual time taken will be 7 hours. Option C is the right answer. Yes, option C is the right answer. See, remember, they have given 3 hours and here answer also they have given hours. So we are not converting anything. So we are just applying the value to the formula, right? So the actual time taken to travel the distance is 7 hours. Okay. Rule number 5. When two persons or trains or cars or objects start traveling towards each other from two distinct points at the same time and complete their journey between the points after passing each other in x and y time respectively, then the ratio of their speed is square root of y is to square root of. So consider here person A is standing and here person B is standing. So they are traveling towards each other. Traveling towards each other from two distinct points at the same time. So if they ask to find their ratio of their speed, the formula is square root of y is to square root of x. Let us see the example. Example 5. If two cars start moving towards each other from two distinct points at the same time and complete their journey between the points after passing each other in 4-minute and 16-minute time respectively, then find the ratio of their speeds. As I said, they have asked ratio of their speeds, right? So let us solve this problem. Here x is equal to 4, y is equal to 16. So what is the formula? Square root of y is to square root of x. 16 is to square root of 4. So what is the square root of 16? 4. What is the square root of 4? 2. So if we simplify this, 2 2s are 4, 1 2 is 2. So 2 is to 1. Ratio of their speeds is 2 is to 1. Option B is the right answer. Yes. Option B is the right answer. So with this we are completing the problems related to moving objects. Okay, let us move on to the next type. Problems related to trains. Case 1. Train versus stationary object of no length. Time taken by a train of length L meter to pass a stationary object such as a pole, standing man or a building is equal to the time taken by the train to cover L meter. Consider you are standing here and a train is standing here with one engine and 4 carriages. So when the train starts to cross you, the length of the train is equal to time taken to cross you. So when the 4th carriage has crossed you, you will say that the train has crossed you, right? So for this process there will be a time taken, right? So length is equal to the time taken by the train of length Lm to pass a stationary object, that is u, is equal to the time taken by the train to cover L meter. So if you know the length of the train and time taken, you can easily identify speed of the train. Let us see the example. Example 6. If a train of 500 meter long crosses a pole in 10 seconds, then what is the speed of the train in kilometer per hour? So they have given meter and seconds, so we have to convert them into kilometer per hour. So what is the formula? Speed of the train is equal to length of the train divided by time taken to cross the stationary object. Speed of the train is equal to length of the train divided by time taken to cross the stationary object. stationary object. So what is the length? 500 meter divided by time taken 10 0 0 is equal to 50 meter per second. Now we have to convert meter per second into kilometer per hour. So what we have seen, to convert meter per second to kilometer per hour, you have to multiply the speed into 18 by 5. So 1 5 is 5, 10 5s are 50, which is equal to 10 into 18, that is 180 kilometer per hour. So option C is the right answer. Yes, option C is the right answer. Case number 2, train versus stationary object of certain length. Time taken by a train of length L meter to pass a stationary object of length A meter, such as another standing train, bridge or a railway platform, is equal to the time taken by the train to cover the distance L plus A meter, which means consider this as a railway platform. The train is standing here. The time taken to cross the railway platform is equal to length of the train and length of the railway platform. So if you know the length of the train and length of the stationary object and the time taken, you can easily find the speed of the train. Let us see the example. A train of length 150 meter moving at a speed of 90 km per hour can cross a bridge of 200 meter in, you have to find the time. Okay, so see the question. They have given meter, kilometer per hour, meter and seconds. So you have to convert this 90 km per hour to meter per second. So let us solve this question. Length of the train is equal to 150 meter. Speed of the train is equal to 90 km per hour. So what I said, to convert kilometer per hour to meter per second, you need to multiply speed into 5 by 18. So 118 is 18. So 18 5s are 5 8s are 40, 90. So 5, which is equal to 25 meter per second, right? Now length of the bridge is equal to 200 meter. So to cross the bridge, the train has to travel a distance equal to the sum of the length of the bridge and length of the train. So consider the length of the bridge is equal to L and the length of the train is equal to A. To cross the bridge, the train has to travel its own distance and the length of the bridge. Therefore, total distance to be covered is equal to 150 meter plus 200 meter. Equal to 350 meter. So now you have to find the time taken. So this formula is for speed of the train. Now you have to find time taken. So apply the basic formula. D T S. So to find the time, the formula is distance by speed. So distance equal to 350 divided by 25. Speed of the train is equal to 25. So just take the answer from the answers given here. 25 8s are 5 8s are 40. So it is 200. 25 14s are 5 4s are 20. 9 10 5 2. So it is 350. So 14 seconds. So the train can cross the bridge of 200 meter in 14 seconds. So option B is the right answer. Yes, option B is the right answer. So train was moving object of no length. Here two cases are there. When the train and man move in same direction with a speed x meter per second and y meter per second respectively. So for this type of questions, both the train and man move in same direction, right? So you have to do x minus y, which is equal to length of the train divided by time taken to cross each other, right? Suppose if the man and train, they move in opposite direction, then you have to add x and y. That is time taken, that is x plus y is equal to length of the train divided by time taken to cross each other, right? Let us see the example. A 250 meter long train is running at 100 km per hour. Then in what time will it pass a man running at 10 km per hour in the same direction in which the train is going? So in this case, both the train and man are moving in the same direction. So this is the formula, right? Let us solve this example. So speed of the train with respect to the man is equal to x minus y. So here this is x and this is y. So 100 minus 10. See the question, they have given meter, kilometer per hour, and in the answer they have given seconds, right? So you have to convert kilometer per hour into meter per seconds. 100 minus 10 is equal to 90. So this is kilometer per hour, right? So to convert this 90 into, we have to do 5 by 18. So 18 5s are 90, which is equal to 5 into 5, 25 meter per seconds. So now you have to find, so from the question we know distance covered by train in crossing a man is equal to 250 meter, right? So therefore time taken is equal to length of the train divided by time taken to cross each other. So what is the length of the train? 250 meter divided by time taken to cross each other, that is 25. 10 25 is 250. It's equal to 10 seconds. So option C is the right answer. Yes, option C is the right answer. So train was moving object of certain length. Case number 1. So here you can take object of certain length means another moving train. Okay, so when two trains are moving in same direction with speed x meter per second and y meter per second, where x is greater than y, then you need to do x minus y is equal to length of the first train plus length of the second train divided by time taken to cross each other. Okay, in case 2, when two trains move in opposite direction with speed x meter per second and y meter per second, you have to add both of them, which is equal to length of the first train plus length of the second train divided by time taken to cross each other. In case number 3, two trains of length a meter and b meter, they are moving in same direction or opposite direction with the speeds x meter per second and y meter per second respectively, where x is greater than y, then the time taken to cross each other is, the formula to find the time taken is a plus b divided by x plus or minus y. So you have to use plus when they are moving in opposite direction, and you have to use minus when they are traveling in same direction, right? Let us see the example now. Two trains of lengths 450 meter and 550 meter are moving in same direction with speeds 50 km per hour and 30 km per hour respectively. Then find the time taken to cross each other. So here they have mentioned that they are moving in same direction. So we have to use case 1, this formula. So x minus y is equal to length of the first train plus length of the second train divided by time taken to cross each other, right? So x minus y, first we have to do x minus y, which is equal to 50 minus 30, that is 20. Here also they have given meter, kilometer per hour and kilometer per hour, and the answers they have given minute. So we have to convert kilometer per hour to meter per second, right? So 20 kilometer per hour. So to convert them into meter per second, we have to multiply the speed with 5 by 18. So 10 2s are 20, 9 2s are 18, which is equal to 50 by 9 meter per second. Keep it like this. Now let us apply the formula. X minus y is equal to length of the first train plus length of the second train divided by time taken to cross each other. Which is equal to, what is the length of the first train? 450 plus 550. So what is the time taken? 50 by 9. So 450 plus 550 is equal to 1000 divided by 50 by 9. When you bring this 9 to here, it is in division, right? So when you bring this here, it will become multiplication. So 1000 into 9 divided by 50, which is equal to 9000 by 50. 0 and 0. It's equal to 180 seconds. So to convert 180 seconds to minute, (180 divided by 60), 6 3s are 18, which is equal to 3 minutes. So option A is the right answer. Yes, option A is the right answer. So with this, we are completing this part 2 video of speed, time and distance. In our next class, we will see the previous year questions plus type 3, that is problems related to boards and streams. I hope that you understood what we saw today. If you want any clarifications or if you have any doubts, you can mention them in the comment section or send us a message to our Instagram page at Labasna Dreams. We will clarify them in the next class. Our next class will be on Wednesday. Hereafter, the practice sheet will be sent to you in evening only in our Telegram channel at Labasna Dreams Official. Practice them. So after completing speed, time and distance, let's plan for a test Will that be okay for you? We shall check what we have learned in reading comprehension, direction and distance, blood relationship, and time, speed and distance. So comment your opinion. Let's plan according to that. See you in the next class.